All right, we're going to chomp off the last three review, but they're not review. This is actually pretty new material for you. And the whole concept is this whole idea of what's a radian. And you're going to be using radians a lot in this pre-cut class. So you got to dig your teeth into this one in your brain, okay? So here's where the idea of radians came from. And I think this will help you to understand. So I've got a circle here. We know that a circle has 360 degrees. Keep that in mind, okay? So a half a circle is 180. Now this mathematician took this idea and said, hey, if this is a radius from here to here, in their mind, they thought of it as a piece of string. They cut it and they laid it down from here to here, I'll just say. And this is the distance of the circle's radius. And of course, they connected this and they said, hey, that's a radius 2. And they said, I'm going to call this 1 radian from here to here. Now, I know in geometry class, they always said, don't go by the way things look, but let's do it. Doesn't that look like about 60 degrees? Keep that in mind. So 1 radian is approximately 60 degrees, approximately. Okay, this is just where we're getting started. So then this mathematician said, let's keep going. And so they made another one. Because this is a radius, this is a radius, this is a radius, so this is one more. I'm just going to put an R for rate, or RAD for radian. Then they did it again. I know my drawing's not perfect, but this is a radius, this is a radius, so this is one more radian. So look at it. It can't be exactly 60 because we've got this little slice left over right here. Guess what that slice is? It's 0.14 of a radian. Now, if you kind of get blown away by how things work, this is 1 radian plus 1 radian plus 1 radian plus 0.14. So we have our first formula. 180 degrees equals 3.14 radians. And it just is that way. You know, geometry, 2 pi r or pi r squared. Volume 4/3 pi r cubed. You got this pi thing. It's just lingering. So, anyways, I find that quite fascinating. And once again, it shows itself. Now, with this in mind, mathematicians said, rather than write 3.14 every time, let's make that pi radians. So 180 degrees equals pi radians. From this springs out what I call the automatics. Now, the automatics are the things, after we work with it, you're just going to get really good at it, using some common sense. So if 180 degrees is pi, then 90 degrees must be half of this, which is pi over 2 radians. Well, let's keep going. How about 60 degrees? Well, you divide 180 by 3 to get 60, so we're going to divide this by 3. We're going to get pi over 3 radians. Now let's talk about 30 degrees. Well, you got a couple ways, 3 ways you could do this. 180 divided by 6 is 30. So we're going to divide that by 6. We're going to get pi over 6 radians. But what you could have done is just taken half of 60 to get here. So half of pi over 3 is pi over 6. You could have divided 90 by 3 to get this, so divide that by 3, you get this. So do you see how consistent this is? But there's one more automatic that you just got to get used to, and that's 45 degrees. What's the easiest way to get it? Well, I noticed that 45 is half of 90, so I divide that by 2, so I got to divide that by 2, so I get pi over 4 radians. You got to know all of these, just like 2 plus 2 is 4. Now, it's going to take some time because it's new, but just know these are your automatics. Also, I want to write this in a different way. If this is, well, actually this. Let me ask you a question. Does 7 equal 7? Please nod and say yes. If I take those two things that are equal and divide them, aren't I always going to get 1? Now this is going to be weird, but 180 degrees equals pi radians. So if I went 180 degrees and I divided it by pi radians, that also equals 1. Now if I flipped it and went pi radians over 180 degrees, that would also equal 1. These two truths are going to be very, very instrumental in some of the problems we're going to do here coming up. So number 1, you got to know this. Number 2, you got to know this. And I'm going to show you why in a minute. All right, a simple truth in math. Anything times 1 is itself. In other words, if I multiply a fraction or anything times something that equals 1, I'm not changing its value. I know that's kind of like, well, duh. Now watch. Look at it. This fraction equals 1. So I can multiply anything I want by this, and I'm not changing its value. I can multiply anything I want by this, and I'm not changing its value. So this is different. This is like our 7 over 7. This is like our 7 over 7. So now we've got these problems. These are your non-automatics. Because if I said, hey guys, what's 45 degrees? You should go, oh, that's pi over 4. That's an automatic. All right, you'll get better at it. These are your non-automatics. So you have to have a strategy. Well, I'm going to take 200 degrees. Now watch this. I'm going to write it like this, 200 degrees over 1. And I'm going to multiply it by one of these two things. Now I got to give you a little mini lesson. 2/3 times 9/8. I teach my classes. My left arm is a fraction. My right arm is a fraction. When I multiply fractions, I cross reduce and I swoosh. So that's 3 goes into 9 3 times. 2 goes into 8 4 times. I swoosh and I get 3/4. Now keep that in mind. Remember, we're changing it from degrees to radians. So we want our degrees to cross reduce. Notice this DEG is in the top. I need DEG in the bottom, so they cancel. That means I need this one. Instead of having that symbol for degrees, I'm going to put the little symbol or the words or the, oh boy, yeah, that. And that's 180 degrees pi radians. Now watch this. These cancel. And then we've got an interesting little problem here. We have 200 times 3.14. Don't type in 180 for that. I know we said 180 degrees equals pi radians. So some of you are going to go, oh, I'm going to put 180 in there. You'd be saying 180 radians. Remember, 1 radian is 60 degrees, and that's what we have here. We have 3.14 radians, which is 180. So that's why we're going to type in 3.14 for that. So I'm going to get my calculator out. Whoops, misplaced it. Okay, so I did the math. 200 times 3.14 divided by 180. Remember, don't forget we got radians. I got it on my calculator is 3.48 radians. Now remember, 1 radian is about 60. So if I have 3 times 60, that's 180, plus another half of a radian, we're getting in the ballpark here. So that makes sense. We're going to do the same thing for 11 degrees. So I got 11 degrees over 1, because I want fractions. I'm going to multiply that by pi radians over 180 degrees. Remember, these cancel. So now I'm going to go 11 times 3.14 divided by 180. Give me a second, save you some video time. All right, so here's the math. This times 3.14 divided by 180 is 0.19 radians. So 1 radian is about 60. A half a radian is 30. So 11 degrees makes sense that we have 0.19 radians. I hope that's just kind of making sense. So now we're going to convert the other way. Okay, so now we're converting from radians to degrees. I've got this on the board for a reason. This is supposed to be an automatic, but I'm going to show you a little trick. Converting from radians to degrees is a lot easier if there's a pi involved, because look at pi radians equals 180 degrees. So I could just substitute 180 degrees in for pi, and I get 45, because that's what I get. Now, yes, I want you to memorize this, but I'm showing you what to do in a problem like this. You don't really need a formula. All you need to do is go, hey, I know pi is 180. So now I'm going to go 3 times 180 divided by 7. Let me do that really quick. That's 540 divided by 7. 77.14. So that's 77.14 degrees. What about this one? Well, this one, I got to use one of these formulas because there's no easy little substitution. I got 4.3 radians. Now we can do a little computing in our head. 1 radian is about 60. It's a little less. So 4 of them would be 240 plus another 20 would be about 260. That's my guess. Well, let's get more accurate. It's 4.3 radians over 1 times, remember, I want my radians to cross-reduce, so now I'm going to use this one. I'm going to use 180 degrees over pi radians. See, we wanted our radians to go bye-bye so that we have only degrees left. And now you just go 180 times 4.3. See how close I got. I don't remember what I said, though. 774. Whoa. Whoa. Give me a second. Oh, I forgot to divide by pi. So divided by 3.14. There it is. 246.5, basically. 246.5 degrees. So we were pretty close with our guesstimate. So there's a strategy for you. Don't forget, there's automatics, and then there's non-automatics. You need these for your non-automatics. All right, next chunk, last chunk. I've got an XY axis. I've got quadrant 1, 2, 3, and 4, and I've got this thing I call a spinner. Now, technically what it is it's a radius, and we're just spinning it around and around a circle. And I just don't have the circle on the board. So, here's the thing. If I take my thumb and I hit the spinner up equals positive. So the opposite is true. Down, going against the order of the quadrants, down is negative. Now, this is called standard position because you always start in this spot. Always, 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 always. Now, what they're going to ask you to do is they're going to ask you to spin it something like 2 pi over 3. So do you see they're messing with you? Now you have to be able to convert this to degrees. Now, here's a trick. Pi over 3, that's supposed to be an automatic. That's 60 degrees. So what's 2 times 60? 2 times 60 is 120. Now, how else could you have done that? You could have went, 2 times 180 over 3. 3 goes into 180, 60 times 2 is 120. So now we got to take our spinner, hit it up, Y up, because it's positive. We go up, and then we keep going 30 degrees. So we went 90 and 30, and then our spinner, sorry that it changed colors, stops right there. Now hold a second. All right, this is the last thing I need to show you. They come with a new phrase. It's called coterminal angles. That means they just end in the exact same spot. But they're going to mess with you with degrees and radians too. Good for them. So, how do I go back to standard position, spin it the same direction, and end up here? Well, I first got to go here, and then I got to go all the way around again, which is a different way of saying 360 degrees. Well, if pi is 180, then 2 pi is 360. So what I need to do, if they want us to answer it in radians, is I need to go 2 pi over 3 plus, let me erase that, 2 pi. Which I'm going to make common denominators and make that 6 pi over 3 plus 2 pi over 3, which would give me 8 pi over 3. So if I spin my spinner this far, I'm going to go and stop right there. but if I spun my spinner this far, I'm going to stop right there. Same positions, they are coterminal. Now, how could I do this in degrees?